Collective intelligence. Collective intelligence is the process by which a large group of individuals gather and share their knowledge, data, and skills for the purpose of solving societal issues. Characteristics of collective intelligence include absence of central control, where individual agents have low cognitive function, but as a group they are able to achieve greater tasks. These agents can alter their surroundings, affecting the group dynamics. We move on to simulating the natural phenomena of stigmergy and swarm intelligence. The first experiment was a time-lapse of how the ants forage for food and how the collective intelligence comes into play. There are two pieces of watermelon which were introduced at different distances from the nest. The ants move randomly till they discover the food and upon discovery go directly to the nest. The ant which discovers the shortest route returns to the nest first, so they are able to optimize their foraging, and we can see certain pathways being established. The next experiment was to create an ant jar and observe the behavior of various ant colonies. These are 60-minute time lapses of tunnel formation in a colony of fire ants. Over the span of 7 to 10 days, these tunnels were created in the jar. Further, we moved to simulating the observed phenomena, first at the swarm level and then at the individual agent level. First, we simulated a swarm with wandering movement. Patterns emerged from the trails of individual agents. An attribute of attraction towards food sources was developed. Here, absence of pheromone trail results in no optimization in the route created. Next attribute was repulsion from the obstacles in path. Here, based on presence of pheromone trails, flocks start building clear paths for themselves. Next, we move to the behavioral production and material system. A multi-agent system is proposed as the production system, which has Pathfinder bots negotiating with the terrain. The doodle bot moves based on random vibratory motion, while the drawing bot moves along a pre-coded pathway. The maker bots follow trails of the pathfinders and consists of the trail follower and the layering bot. Sand is chosen as the material as it has potential to allow the building to naturally decay and become part of the source again. The behavior of the material was studied, and for smaller scale model explorations, it was substituted with powdered sugar, which has similar material properties. The process of sinting, which is the fusion of material through heating, was chosen. When heat is applied, the sugar particles start melting and form smaller molecules. The particles come together due to the air pressure from the heat gun. The molten particles fuse together and start forming solids. Layer by layer it is built upon, and complex geometries are achieved. These are some of the model explorations and the emerging light and space quality. For 3D visualization of stigmergy trails, depth was added to create spaces. A CNC model was created with a negative mapping of the trails. The explorations for forms and volumes continued. Here the radius of the trails is increased. The positive and negatives volume simulations were created. Further on, various iterations were created for digital prototype. The forms emerged from flocking and stigmergy behavior. Certain emerging forms resembled the sugar sintered models. Some forms resembled the ant nest architecture observed earlier. Here, the form has tunnels similar to the ant nest. The digital prototype proposes a multi-agent building system. The multi-agent bots consist of the Pathfinder, sinting, and layering bot. The Pathfinder creates a trail, the sinting bot sinters the surface, and the layering bot layers sand on top. Slowly, we see the building system as a whole. The red outlines in the plan and section show the sintered areas. The mass results from the filled sand with the sintered walls separating them from the voids. The prototypes were visualized as spaces to understand the emerging spatial character. Possibilities? How can we make habitable spaces in the deserts in a more appropriate manner? Can these spaces counter desertification? In such a landscape, can we build in a way that negotiates with these phenomena and our need for habitation? Can we build with a material which is borrowed from the desert and at the end of the building's life lends itself to the earth again? How are we to live with the desert, in the desert, within the desert? How to start rethinking about the way we build and our relation to the built environment? Building in a more conscious way. Awareness to the life cycle of the building, to the material waste generated in the construction process. Desert of Jordan selected as site. Project brief. Small settlement for 30 to 40 people. Bots as part of a herd. Dune, a dwelling in the desert. From the exploration of collective intelligence, we arrived at the brief of a community habitation unit. The project attempts to create community habitation unit within moving dunes close to human settlements by stabilizing their form, thereby countering wreckage of built due to sandstorms, desertification, and dune migration. The Proposec multi-agent system involves a very context-driven manner of designing and production. The idea here is to identify the topography and use vernacular or regional building elements and space usage as cues for the design of the spaces, and arrive at a system of space making which can be replicated and contextualized for the particular terrain. Contextualizing. The site is located in the Thar Desert, and after understanding the different dune types, the parabolic Ahn-Burchen dunes were the chosen profiles as these tend to migrate. The design process was broken into parts involving space organization, circulation, addressing climate, and the making process. A typical Burchen dune profile was taken with the migration of the dune from the southwest along the wind direction. The space division was based on the vernacular architecture and village organization. This region has strong community bonds that the design attempts to foster. Cues were taken from ant nest architecture. The vertical spine translated to the atriums, which would bring in light and ventilation. To optimize the planning, circle packing was used to pack spaces based on the density of individuals in that place. Posts with stigmary curves were generated as the bot's movement trails. The trails enclose the masses and voids. The stigmergy trails act as input for the next set of agents. These trails were generated based on repulsion, where voids exist, and attraction towards the mass. For the circulation, the voids are organized as stier. The bundling processes the curves connecting all with the shortest path, connecting all the spaces. As response to the climatic conditions, the outer shell is proposed. This stabilizes the dune, and the Thihic mesh network creates thermal mass, allowing temperature regulation. The process section assimilates the aforementioned parts. The public, semi-public, and private spaces are organized within the dune profile, with the central atrium bringing in diffuse light.